We looked at methods of finding some coordinates in that last video. What we're going to do is kind of the same idea here, because that gets us to making a graph, but often some of the coordinates are easier to find based on the form that we're given for our function. So we're going to look at three forms. There's standard form, vertex form, and factored form. So in standard form, information that we have coming through here. So in that last video, that's what we were working with. It was that idea that we're seeing a value for a, like in this case, this negative x squared plus 10x minus 16. So we have a equals -1, we would have b equals 10, and we have c equals -16. So some information I can get out of this right away is whether it's opening upward or downward. In this case, it would open downward. I would have the y-intercept pretty nicely, because that would just be when x equals 0 and we're left with that value of c, so 0, -16. And then we could calculate the vertex by using the -b/2a. I'm not actually going to calculate the whole thing here. This is just an example. And then plugging in that -b/2a to find the y-coordinate. And then, as we did in that last video, we can solve for the x-intercepts. It just takes some steps, but in terms of what's available right when we're given the standard form, see which direction it's opening in, the y-intercept, and then the vertex. The x-intercepts are there, we would just have to factor. In fact, maybe I'll make a note of that. For the x-intercepts, we would need to factor and solve. All right. So in standard form, that's where we can get going. This form right here is vertex form. So vertex form. And we can see the general form down below here. So the general form goes f of x equals a times, and then in parentheses, x minus h squared plus k. And what we're getting is this value of h is our x coordinate of the vertex, and the value k is the y coordinate. Now, something to pay attention to is that we have subtraction next to h, so it's an x minus h squared. And when we go to the vertex, we're just taking the h value. So what I'm trying to emphasize here is that this subtraction is part of the form. So let's go up to this example here, where we see in the parentheses x minus 5 squared. That means the vertex has an x coordinate that is +5. So even though I see x minus 5, we expect that minus to be there, so the x coordinate is actually a +5. And then nothing special with the y coordinate, you just copy whatever there is, so we see a +9, so that's a +9. So basically with the x coordinate, it's going to go opposite of what it looks like in the vertex form. So with subtraction, the x coordinate's positive. If we had addition there in that form, then the x coordinate would be negative, because it's like we have a minus -5 or whatever we're doing, and it would simplify to x plus 5. Our value for a is actually showing through here, so this negative in front of the x minus 5 squared, this is actually a case of a equals -1. So I would see this a equals -1. So this also tells me whether it opens upwards or downwards. And because that's a -1, this would be it opens downwards. We can get the y-intercept pretty easily. So for the y-intercept, we're just evaluating. In this case, g of 0. So you're plugging in x equals 0 and solving, which isn't too bad. For the x-intercepts, we would have some work to do, but it wouldn't be too bad. We would solve using the square root method. So let's get a little review of that. And actually, I'm going to check, I believe down here, yeah, we're going to look at a case with the vertex form down below. So I'm going to save that for then, but basically we can use a method to solve for those x-intercepts. It's a little easier than factoring, but basically we get that vertex, we get the direction, we get the y-intercept and x-intercepts. Just the vertex in this is very clear. We don't have any calculations that we need to do like we did in the standard form. All right, then our last one here is our factored form. And this is nice for one thing, the x-intercepts. So with the x-intercepts, like for this one, I would be setting 0 equals negative x minus 2 times x minus 8. And then I would see, okay, x minus 2 has to equal 0, x minus 8 has to equal 0. So we're getting x equals 2, x equals 8. So we get 2 x-intercepts, 2, 0, 8, 0. And really this kind of rule follows through, like this was x minus 2, so the x-intercept is positive 2, 0. X minus 8, positive 8, 0. So it's going to kind of switch sign of the x-coordinate, and then the y-coordinate will be 0. We can also, we kind of see A with this one, but it's a little tricky. I don't really want to say much more about that. Getting the y-intercept wouldn't be too bad because we would just be plugging in x equals 0. But typically with this factored form, what do I want to say? With this factored form, I would use this to grab the x-intercepts, maybe the y-intercept, but then what I would do is change it to standard form. So I'd FOIL it out and simplify so I can use that standard form of ax squared plus bx plus c, and then I would find the vertex in the other information. I would check my value for a and seeing whether it's opening upwards or downwards. So the factored form is nice for limited uses here, but basically with quadratics, those are the different forms we could see coming through here. So standard form, ax squared plus bx plus c. Factored form shows you the intercepts that are occurring, and then the vertex form shows the vertex. Okay, so what we're going to do is go through some examples where we're given a function and we want to graph it, or rather make a sketch of it. We're not going to graph it perfectly. And what we're focusing on is using this value of a, using the vertex, and using the intercepts to get the graph going. So this first one, 1/2 times x plus 4 in parentheses squared plus 3. So this is our vertex form. So what I can immediately do is get the vertex out of that, so in the parentheses is an x plus 4, so that means x is going to be negative 4 in my vertex. And it's kind of switching its opposite. And then that plus 3 tells me positive 3 for y. So I get this coordinate negative 4, positive 3. And then my value for a is a positive 1/2. So because it's positive, that tells me it's opening upwards. So that's just giving me an idea of the general shape. And if it's opening upwards, there aren't going to be any x-intercepts. But let's say we didn't realize that. Okay, y-intercept we can do, it's just plugging in x equals 0. So I'd have 1/2 times 0 plus 4 squared plus 3. Let's see, that's 1/2 times 16, so that's 8 plus 3, so that's 11. So that's actually off the page here. Like my grid's only going to 8, so I'm not actually able to graph the y-intercept. That's okay. So let's say I tried to graph the x-intercepts. So 0 equals 1/2 x plus 4 quantity squared plus 3. And I'm going to go through the steps as if we were solving this, even though I know it's going to cause an error. But what we would do is we want to isolate this piece that is squared. I would want to isolate that x plus 4 squared. So what I'm going to do is subtract 3 from both sides, multiply both sides by 2. So I'd have -6 equals, and then multiplying by 2 takes care of that 1/2. So then I just have -6 equals x plus 4 squared. And then that square root method that I mentioned up above there would be the case of where I take the square root of both sides. So what we would end up with is on one side of the equation, so like the square root of x plus 4 squared is just x plus 4, and then we'd have equals plus or minus. So we'd always have this plus or minus because we want all possibilities. But in this case, we're taking the square root of a negative number, and we can't do that. So what that tells me is that there's no x-intercepts, which makes sense since we have that vertex that's above the x-axis, and then if it's opening upwards, we're never going to cross that x-axis. So with all of that, all I have graphed right now is the vertex -4, 3. And I know that it should be opening upwards, but I need at least one more point to graph in order to do this. So the y-intercept is off the page. We don't have any x-intercepts. So what I'm going to do is just make a table of values. And I'm just going to look close to x equals -4. So let's look at x equals -3. So let's see, that would be 1/2 times -3 plus 4 squared plus 3, which is 1/2 plus 3, so 3.5. So what I'm going to do is graph -3, 3.5. And then because of symmetry, so notice that like from the vertex, we go to the right one and up 1/2. The same thing would be happening on the other side if I go to the left. So if I go to x equals -5, that's also going to be 3.5 for the output. And then you could keep plugging in points, but really you just need those pieces to get the graph going. We just want to sketch. That got pretty wobbly at the end. Let me try that again. So there's our sketch. So we used A, so we knew the direction. Since it was vertex form, we got the vertex out. But then the other pieces, the y-intercept is useful, but not in terms of making our sketch here, just because of the limitations of the grid that was provided. And then the x-intercepts didn't give us anything since they were undefined. So with that, we start kind of just plugging in values, and we can make a whole table, and then also using that symmetry. Okay, so what if we're given this -3x squared minus 24x minus 47? So here we are working with something that is in standard form. So with this, A is -3, B is -24, C is -47. So if A is -3, since it's negative, that tells me it's opening downwards. That gives me a general shape to follow. We're going to have the coordinate 0, -47, which is way off the page. So we have our y-intercept there that I don't think we'll be able to graph. And from there, let's see, let's find the vertex. So for the x-coordinate, we're taking -b, so -24 over 2 times a, so 2 times -3. So that numerator is going to be +24, and then we're dividing by 2 times -3, which is a -6. So that's going to be a -4. And then we're just going to find f of -4. Let's use the calculator for plugging in -4 to our quadratic. So let's see here. I'm going -3 times -4 squared minus 24 times -4, and then minus 47, which is +1. So we have the vertex -4, +1. -4, +1. All right, so we have A, we have the y-intercept, we have the vertex, and now let's find our x-intercepts. And you know what? I just realized this doesn't factor nicely, and at this point in our videos, we're only using factoring. In one of the next videos, we're going to talk about the quadratic formula, so I'm just going to make a note to myself here. Let's return to this problem and use the quadratic formula to find those x-intercepts. So we'll do that later. But for now, let's say we tried to factor it. We couldn't. We know we're opening downwards, so there are some solutions there. But for now, just to get some extra coordinates to graph, let's make a table. So let's look at, let's see, we're at -4, 1. Let's look at plugging in -3 again. And let's just go to our function here. So if we plug in -3 into our function, we're going to have an output of -2. So we have the coordinate -3, -2, which means we also have -5, -2, just from symmetry. And then you can find more coordinates, but really that gets us going in terms of our values. All right. So yeah, we'll come back to those x-intercepts, but they're a bit messy, and it's coming from the quadratic formula. Okay, let's work on, if you're given a graph, finding the quadratic function to match it. And with these, there's a few ways to go about it. You can choose between starting with the factored form or the vertex form. I wouldn't recommend starting with the standard form, but typically you want to get started with either using the x-intercepts as the factors or use the vertex. With these, I'm not going to use the factored form because those x-intercepts are landing kind of messy spots. So what I'm going to do is use the vertex form. So as a reminder, our vertex form is a times x minus h squared plus k. So in this first graph, our vertex is the coordinate 1, 7. So with that, if I'm plugging into the vertex form of the graph, I'm going to have f of x. We are not going to know what a is yet, so I'm going to leave a as a value in there. But then I'm going to go x, and then, so it's minus h when we have a positive x coordinate. It's going to be plus h when we have a negative x coordinate. So because our coordinate is positive 1, I'm going to have x minus 1 in the parentheses and then squared. And then plus whatever the y coordinate is, so that's a positive 7, so we'll have plus 7. Now, to solve for a, what we need to do is plug in a different coordinate, a coordinate that's different from our vertex. So what I want to do is just find a value that's clearly defined along my function. The y-intercept can be really nice. In this case, it is clearly a 0, 6. If it was kind of messy, then I wouldn't want to plug it in, but that's clearly defined as 0, 6. So what I'm going to do is look at if I have an output of 6 equals a times 0 minus 1 squared, so plugging in 0 for x, and then plus 7, which is 6 equals, so 0 minus 1 squared is just a 1, so a plus 7, subtract 7 from both sides, so a is going to be a negative 1. So my function, f of x, equals negative x minus 1 squared plus 7. And I just do a quick check that that makes sense, like the a being negative, yep, it's opening downwards, so that makes sense. We have our vertex in there, and then we just use that other coordinate to help us find that value for a. All right, for this case here, our vertex is here at -4, -6. So setting up my vertex form, we're going to have f of x equals a times, and this is going to be x plus 4 squared. So we'll have a plus 4 because there's a negative 4 x coordinate. And then with y, so the y coordinate is a negative 6, so we have a minus 6 at the end. So a times x plus 4 squared minus 6. All right, we need to solve for a, so we're going to look for a coordinate that we can plug in. The y-intercept looks pretty nice here with the 0, 2. So output of 2 equals a times 0 plus 4 squared minus 6. So that's going to be a 2 equals a times 4 squared, so that's a 16a. And let's see, minus 6. Add 6 to both sides, that is 8 equals 16a. Divide by 16, and that's going to be that a is a positive 1/2, which makes sense with that parabola opening upwards. So f of x equals positive 1/2 x plus 4 squared minus 6. So with those ones where you're finding the quadratic function, make sure you leave a as an unknown because we need to solve for it using a second coordinate, but you can use the vertex to get that function started.